Hello and welcome to our class dedicated to percent change. In this class, we'll start with a simple example, then we'll proceed to discussing percent increase and percent decrease. Finally, we'll learn how to solve percent change problems. First of all, let's try to answer the question. What is $100 increased by 10%? In order to answer this question, we can follow a two-step process. First of all, we'll find 10% of $100. This, of course, will be $10. Then we can add $10 to $100, and we'll obtain the result. $100 increased by 10% is $110. This two-step process is not efficient, of course. We can try to revise this solution. We can add 10% to the 100% of the base. The base represents 100%. So we'll notice that increasing a base by 10% is the same as finding 110% of the base. With this in mind, we can rewrite this solution as a one line. In this case, 1.1 is the rate per 1, which is equivalent to 110%. The base is 100, so the product is 110. We obtain the same result, but in this case, we find 110% of $100. Let's try now to answer this question. Increasing a base by 2.5% is equivalent to taking what percent of the base? The base is 100%. We increase it by 2.5%, so we'll find 102.5% of the base. Well, this percent, which means this rate per 100, stated as the equivalent rate per 1, would be 1.025. For example, 50 increased by 2.5% would be 51.25. This time we'll answer a general question. Increasing a base by R% is equivalent to taking what percent of the base? The answer is 100 plus R%. This percent stated as the equivalent rate per 1 would be 1 plus the rate per 1. In this case, the rate per 1 is R divided by 100. We are ready to see the percent increase formula. This formula connects the base and the forward value. The forward value is the value obtained when the base has been increased by R%. If we use R small to denote the equivalent rate per 1, that is, R small is R big divided by 100. We'll simplify this formula. Again, this simpler formula connects the base and the forward value. But in this case, R in this formula is the rate per 1. Let's now proceed to percent decrease. We'll ask a similar question. Decreasing a base by 5% is equivalent to taking what percent of the base? It is 95%. Decreasing a base by 5% is the same as finding 95% of the base. For instance, 50 decreased by 5% would be 47.5. In this example, we found 95% of 50. Similarly to percent increase formula, we can build percent decrease formula. In this formula, the forward value f will be connected with the base b. But this time, the rate per 1 will be subtracted. Let's review. We have obtained two formulas. First is the percent increase, and the second is the percent decrease. Now we are ready to solve some percent change problems. Problem 1. Share open price has increased by 4% to become $100 at close. What was the open price? We know the forward value. It is $100. We do not know the base, therefore we'll use letter B to denote it. We can build an equation which connects forward value and the base. This is the equation for percent increase, because the question is about increase. So we'll find B. And this will be 96.15. This answer means that the open price, $96.15, after the increase of 4%, has become $100. There is a typical mistake which people make in this problem. They decrease the forward value instead of increasing the base. The incorrect solution with this confusion becomes $96. Please watch out for this mistake. Problem 2. Daily sales volume decreased from 120,000 to 112,000. What was the percent change? We know the base, $120,000, and we know the forward value. It is $112,000. We need to find the rate, and again we'll use a letter to denote it. Let letter R be the rate per one. We can build an equation which connects the base and the forward value. This is the equation for percent decrease. That's why we remove the rate per one from 1. We can solve this equation, and we'll find that the rate per one is 0.0667. That's the rate per one, so we'll convert it to percent, and we'll find the answer. That is 6.67%. Therefore, 120,000 decreased by 6.67% is 112,000. Now we are ready to proceed to our problem 3, which is the major problem of our class. During the month, the price of a commodity, which initially had been $1,200 per ton, changed 8 times in the following way. First, increasing by 0.5% and then decreasing by 0.5%. This pattern repeating 4 times. What was the price of the commodity after all changes? Let's consider the diagram for this compound process. We call this process compound because the word compound means consisting of several elements. In this case, we have several increases and decreases. We start with $1,200. This amount is increased by 0.5%, and then the resulting forward value will become the base, which will be decreased by 0.5%, and so it will go until we reach the final forward value F. Let's check out mathematically what happens with $1,200. We start with this base. This base is increased by 0.5%, then it will be decreased by 0.5%, and so it will go for 8 iterations. Let's consider this process separately now. Because multiplication is commutative, we can rearrange the factors. We can collect all increases together, and we also can collect all decreases together. We can use exponents to simplify this process further. Because exponent is a repeated multiplication, we can write this expression now very simply. The answer will be $1,199.88. This means that the price of $1,200 after 8 changes becomes the final forward value, $1,199.88. In the previous problem, we had the following percent changes. We had 4 increases of 0.5% and 4 decreases of 0.5%. We can make the following observations. The sequence of percent changes does not make difference. This is because multiplication is a commutative operation. The 8% changes are equivalent to a single percent decrease of 0.01%. And this single percent decrease can be found without using the base and the final forward value. This equivalent single percent decrease can be found from the following equation. In this equation, R is the rate per one. On the left side, we see a single percent decrease. On the right side, we see 8 changes. We can solve this equation now for R, and we'll find that R is 0.0001. This is the rate per one. Therefore, 4 increases of 0.5% and 4 decreases of 0.5%, and that is in any order, are equivalent to 1% decrease of 0.01%. Let's debrief. Percent increase formula connects the forward value and the base. In this formula, we add the rate of increase. Percent decrease formula also connects the forward value and the base, but in this formula we subtract percent decrease. It is of big importance to find the changed percent of the base rather than to add the percent of change to the base. For example, $100 increased by 10% must be solved by finding 110% of $100. It is much better than solving it by finding 10% of $100 and then adding that to $100. Why it is so important? Because it allows us to solve compound percent change problems. For example, if I ask the question, what is $100 increased by 10% 10 times? It would be very easy to solve by finding 110% of the base each time. Because there are 10 changes, it simply is power 10. So in this case, the answer would be 259.37.